Edison said don't record for you guys. I'm throwing him under the bus. Okay. Intermediate value theorem for derivatives. Here we go. If I give you two values, A and B, if A and B are any 2 points on an interval. Okay, so let's draw. Do you guys have space right above it for a picture?
Yeah.
Okay, so let's draw it here. We'll draw it as we go. So let's call it A, let's call it B. There you go. Any 2 points on an interval on which f is differentiable. Okay. So that means for a function f to be differentiable, would you agree that it has to be smooth and continuous? What? Perfect. There you go. A and B. Made of some curve. Does that function looks differentiable? Yeah, looks good. Okay. Then it went on further and said, then f prime takes on every value between f prime of A and f prime of B. So if I were to do, let's pretend, if I were to do the derivative of A, let's pretend that this right here will be f prime of A. Okay? And let's pretend this guy over here is f prime of B. Okay? Now, what does that all mean? This all meaning in simpler language, okay? Meaning if f is differentiable, which we drew that, made up that function, and it looks like it's smooth and continuous. If f is differentiable between A and B, and suppose there is a y value between f prime of A and f prime of B. Oops, f prime of B. So let's go and find a y value. Would you agree that I can find there is a y value? Oh, a lot of y value. Well, let's pretend that this is a y value. Is that okay to say that's a y value? Is that in between f prime of A and f prime of B? Sure. Looks good. Okay, so we did that. And said, hey, suppose there's a y value in between the two derivatives. Then, based on the theorem, based on this intermediate value, then there is a c value. And this c value is in between A and B. Okay, and there's a c value such that, do we remember that backward f is such that? Oh no. Do we ever use that in this class? Backwards f? Once. Backwards f is such that this c value belongs in between A and B. Okay. I picked that y value randomly. Is that true? Is that a c value in between A and B? Yes or no? Yes. Yeah. So that's all I was saying. So hey, if there's a y value in between the two derivatives, then there's a c value in between A and B. Okay. So, but one more, I will take your answer. Okay. Now, so that that y value, it's actually, okay, and so we're going to continue. I don't have any more space, so here we go. And that y value, guys, is equivalent to the derivative of c. Okay. Okay, so pick any random y value, and that should be in between the derivative of the two. Then that means there's a c in between A and B. Okay, great.
Is that that graph is x and y prime with it? I mean x and y prime. Like, is that a derivative graph that you just drew?
No, that's just a regular graph that I drew. But like, I'm just picking like a random derivative point. Like, oh, okay, let's just say this is a let's just say that it comes out. It doesn't have to be positive negative slope. Let's say this is not a steep, so let's say it's like 1 or 2. Okay. Over here, let's say it's a little bit steeper. Since I made up the graph, it's not going to be as accurate. So let's say that, okay, there's like a derivative at 5. Okay, so if there is a y value at all in between the two derivatives, let's say there's a y value at like 3, okay? Then that means that y value that you've chosen on the function, regular function, should be equivalent to the derivative of c. So in between those two should have, so these two should match up. Okay, so no, that's just a regular graph that we made up. So that's why I did write on the top y prime. So it's a made up graph, so obviously the steepness is not going to make, or it's not going to be as accurate. Okay, 3.3. Addison, read me 3.3. Title.
The rules for differentiation. Yippee! This is where finding a derivative gets easier.
Right. This is where you can catch up with those physics kids. Okay. All right. I'll start with an IE over here. Derivative of a constant. We'll start with an IE in the derivative of a constant. Y equals 2. What kind of graph is that?
Straight line.
Straight line. Here we go. Y equals 2. We're just making up a constant function. Tell me about y prime. What's y prime? 0. It's a flat line. The slope is always 0. All right. So that means, based on that, derivative of constant. Definition, d over dx of any constant number, let's call it c, should always be 0, where c is any real number. C belongs in the set of all real numbers. Next question, i.e., y to the third is my function. If I were to sketch that out, y equals x to the third. I'm sorry, y equals x to the third. I got too excited. Yeah, y equals x to the third. Would you agree that looks like that? And we sketched the derivative. What was the derivative? Okay, this is just a sketch, so this is y prime. So based on that, I'm going to say derivative with respect to x of any function to the n power. Okay. I'm going to take down the n, the power, times x, and then whatever's left, we're going to subtract it. Okay. Where n is any number. Where n is any number. So if I have y equals x to the third, why do you think it becomes a parabola? Y prime is 3x squared. Yippee! Now, tonight's homework though, since you're still on 3.2, you have to use, okay, don't use this cheat sheet yet. Next, constant multiple. Okay, so the rule says, with obviously still respect to x, of some constant, let's call it c, times some function, let's call it f of x. What does it equal? So here's i.e. f of x equals 4 times x to the third. What do you think the derivative is? You're going to keep the 4, you're going to take the 3, bring it down, and then you subtract the power. So 3 minus 1 is now 2. So that's why this is a 12x squared. Okay, so based on the rule that we have, we're going to say equals c times f prime of x. Okay. So we did x to the third normally as a normal derivative. Would you guys agree? Okay. Next, sum and difference, okay? d of dx, if you have two functions, f of x plus or minus g of x, you can take them independently. It becomes f prime of x plus or minus g prime of x. Linear function. What degree is linear? 1. So g divided by dx of n times x. What do you think the derivative is?
Or n.
N. Okay, so let me give you a linear. Negative 1/2 x minus or plus 1,000. What's the derivative? Negative 1/2. Thank you. Because what's the derivative of 1,000? It's 0. It's nothing. It went to 0. So it's always n. It is linear. And this is where we are going to stop today.